Hey, Astro fans! Something a bit different today. Fission versus fusion. Alright, cool. So, what's the difference? They do sound similar, and they are both to do with atoms, but essentially they're sort of opposites. Let's start with fission first. Fission is the name for the splitting of an atom, which sounds tricky, but if you have the right isotopes, then it can be done. What you need is something unstable. An isotope with so many extra neutrons that the binding energy of the nucleus isn't enough to keep it together anymore, and poof, it splits. A couple of examples of these are uranium-235 and plutonium-239. If you shoot neutrons at them, they become unstable and fission begins. The nucleus from the original atom splits into two further nuclei plus a few neutrons, which then hit more unstable nuclei and more and more. It becomes a chain reaction. Now, you may have heard of uranium and plutonium before. They sound cool and are used as fuel for nuclear reactors. This is because the reaction generates energy. When the nuclei split, neutrons and gamma-ray photons are emitted, and it is a lot of energy. 200 million electron volts. That's roughly the same as having 2,000 medical x-rays at once. Now, how about nuclear fusion? I said they were sort of opposites, and that's because fusion is the joining of atoms, as opposed to the splitting from nuclear fission. But fusion doesn't happen here on Earth. It requires an extreme environment. Nuclear fusion happens in the cores of stars. It's a star's fuel to make it shine. And while fission involves heavy elements like uranium-235, fusion starts with the simplest element first: hydrogen. What happens in most stars is the fusing of hydrogen into the next simplest element, helium. But if you have a bigger, brighter, older star, you can fuse more complicated elements too. So if this process makes the stars shine, then that means it must be releasing energy too, right? And it does. For each of those hydrogen fusion reactions, 25 million electron volts of energy is released, which would have sounded more impressive if it was bigger than the 200 million from nuclear fission. However, fusion is more efficient. You only have a few particles being fused together, whereas fission requires a couple of hundred before you can even get going. The energy per particle in hydrogen fusion is roughly 7 times that of uranium-235 fission. Because of that, scientists are currently trying to figure out how to make nuclear fusion happen here on Earth as a future energy source. Until next time, keep being curious.